Hello again, and welcome back to Semester 11 Math. Today, we're going to be talking about arithmetic series. What we know so far is we know what an arithmetic sequence is, and we also know what a series is. But what we're going to do today is we're going to combine the two. So we're going to talk about arithmetic series. We're going to do a few questions in regards to these, and we're also going to go through a derivation of the formulas that we will use, but that will be at the very end of the video. So before we get into it, we should recall some definitions. A sequence, we should know, to be an ordered list of numbers. Right? An arithmetic sequence being an ordered list of numbers, but arithmetic means it has the same common difference between consecutive terms. So the same common difference. If any of this is new, we should go back and check out the previous videos because we talked in depth about these definitions before. A series, well, a series is just the sum of a sequence. The sum of a sequence. So with those definitions in mind, what do we think an arithmetic series is? Well, could it be the sum of a arithmetic sequence? Yes, it can be. And that's exactly what it is. So it is just the sum of an arithmetic sequence. We have two formulas that we're going to use in helping us determine an arithmetic series. The first of which, so our first formula, being as follows. S sub n, meaning the series at any given term, is equal to n 2a plus n minus 1 multiplied by d all over 2. Again, we'll go over a derivation of these formulas at the end of the video. But for now, let's just know how to use them. Our second formula is simply S sub n is equal to n over 2, all multiplied by a1 plus an. So just looking at these formulas without any numbers, just looking at the actual formulas, what are some differences? Can we see any differences? Obviously there's differences, or else they would just be one formula, right? So our first formula, what do we need to find the series? What do we need to find the sum? Well, we need our n, which is whatever term we're looking for. We need our a, which is our first term. Again, n is the term we're looking for. And d is our common difference. Conversely, on our second formula, again, we need our n value. We need our first term. But in this case, we need the final term, or the term at whatever sum we're looking for. So in the second formula, we actually need either a final term, like I said. So if we're looking to sum the entire sequence, we're going to need the final term in the sequence. If we're looking for the sum of the first 10 terms, we're going to need the 10th term, right? Does that make sense? So we're looking for, so we need whatever term whatever term we are summing to. Okay, so in the second formula, we need to know our first term and either the last term if we're summing the entire sequence, or whatever term we're summing to, we're going to need that term as well. In the first formula, we do not. We just need the common difference and the first term. So let's go through an example. In this case, it's asking us to use both formulas to determine S sub 11. So the sum of all the terms up to the 11th term. So let's go ahead and write out our first formula. So S sub 11 is equal to N 2A plus N minus 1 multiplied by D, the common difference, all divided by 2. Great. So let's go ahead and plug in the values that we have. So S sub 11, that means our N is 11, right? Our N is 11. 2 multiplied by A is our first term in the sequence. So here it is -3. Plus, again, N is our 11. So plus 11 minus 1 multiplied by D. Now what's our common difference here? Well, our common difference is -3, right? So T2 minus T1. T2 is -6 minus -3, giving us -3 as our common difference. So this is all multiplied by -3, and the entire equation is divisible by 2. So, working this out on our calculators, we should get an answer of -198. We should get an answer of -198. So that's the first formula. What about the second formula? What about the second formula? Second formula, again, is S sub 11 is equal to N divided by 2, A1 plus AN, right? So let's go ahead and try to sub in all the values that we know. Well, N is 11, so we could plug that in. A1, well, A1 is still -3, plus AN. So what is our 11th term? Well, we don't know the 11th term. Yeah, we could figure it out by adding -3 as our common difference all the way until we get 11 terms. We could do that. Or, is there another way we could do that? Well, there is. Using the general term formula, right? So, our general term formula. Again, if we don't know how to do this, go ahead and check out the previous videos. We discussed in detail how to use our general term formulas and also our recursive term formulas. So we see how it all builds upon each other and it ties in to one bigger concept, right? So let's go ahead and use our general term formula. If we remember, our general term formula is A sub n is equal to A1 plus n minus 1, all multiplied by D, our common difference. So A sub 11 in this case, right? Because we're looking for the 11th term, we need the 11th term. Is A sub 1, which is -3, plus n minus 1, so 11 minus 1, multiplied by D, which again is -3. Giving us a answer of our 11th term to be -33. -33. That's great. Now we can go ahead and sub that back in for A sub 11. I am using a different shade of blue. There we go. So we could sub that now back in to our series formula and solve for S sub 11. So we have 11 divided by 2 multiplied by -3 plus negative 33, giving us a sum of up to our 11th term of negative 198. So either formula would give us the same answer, right? Obviously, or else the sum would be different and that wouldn't make any sense. So it doesn't matter, unless I specifically ask to use one formula or the other, it doesn't matter which formula you use because you will get the same answer. So in this case, in our second case, we needed to do another step because we did not know what our 11th term was. Because of that, formula 1 would probably be the easier formula to work with. But again, doesn't matter. If you'd like to use the general term formula to solve for the 11th term in this case, go ahead and do so. It's good practice anyways on how to use the general term formula. So another question that we might get asked is to sum an entire sequence. Is to sum an entire sequence. No problem. We have a formula that would help us. So if we're looking to sum the entire sequence, what formula do you think is best? Formula 1, let's go back, formula 1, where we need our n value and our a1 value, or formula 2, where we need our a1 value, our n value, and also the final term in the sequence. Well, in this case, we're given a1, and we're given the final term. So why not go ahead and use formula 2? Since I didn't ask for both formulas, we can just go ahead and use one. So formula 2 is S sub n is equal to n divided by 2 multiplied by a1 plus an. Great. Let's go ahead and sub in what we know. So S sub n, we're looking for the entire sequence, is equal to n divided by 2. Do we know what n is? Do we know what n is? Well, we don't. Not yet anyways. Because 38 could be the 5th term in our sequence. It could be the 7th term. We don't know, right? We don't know. So we'll keep it as n over 2 for now. a1, we do know, is 5. And a of sub n is simply 38. Great, so how do you think we're going to go ahead and solve for n? How are we going to solve for n? Did you say general term formula? I hope you did. We're going to use our general term formula again. So our general term formula, a sub n is equal to a1 plus n minus 1 multiplied by our common difference, right? So in this case, we're actually given a sub n. So we're working backwards to find out our n value. So we're given a sub n. A sub n is 38. Is equal to a1, which is 5, plus n minus 1 multiplied by our common difference, which in this case is 3. If we go ahead and distribute our 3 into our brackets, we get 38 is equal to 5 plus 3n minus 3. So we should get 38 is equal to, and we collect like terms now, so 5 minus 3, 2 plus 3n. Isolate for n. We should get 12 is equal to n. So what does this mean? Well, this means our 12th term is 38. So 38 is the last term in our sequence, and our last term is our 12th term. So there's 12 terms in this sequence. So that's it. So now we're solving for S sub 12. 12 divided by 2, 5 plus 38, giving us a final answer, 12 divided by 2 times 258. So that is the sum of our entire sequence. That is the sum of our entire sequence. Now, if you want to stick around for the derivation of our formulas, you can. They're not necessary in in our questions. I'm never going to ask you to derive the formula, but it might help you understand the concept behind sequences and series. So let's get into the derivation of our formulas. First, let's write out what an arithmetic sequence is. So an arithmetic sequence. Well, in general terms, it is simply a plus d, a plus 2d, and so on, until we get to our final term of a plus n minus 1 d, right? This is the general term of an arithmetic sequence. So what is happening between our term 1 to term 2? What is happening between each consecutive terms? Well, here we're adding 1d. Here we're also adding 1d. Right? So we keep adding 1d until we get to our final term, which is our number of terms minus 1. That is the amount of d, or the common difference we're adding, right? This is just an arithmetic sequence. So what is an arithmetic series? So what about an arithmetic series? Well, we could write out the same general term. So S sub n is equal to a plus d plus a plus 2d, and so on, until we get to a plus n minus 1 multiplied by d, right? This is just because an arithmetic series is the sum of our sequence. And in general terms, this is exactly what it is. So I'm going to go ahead now, I'm going to add this general term to itself, okay? I'm going to add it to itself. But now I'm going to flip the order. Why? Because I can, right? So 3 plus 2 plus 7 is equal to 7 plus 3 plus 2. So it doesn't matter how we add, just the fact that we add, it doesn't matter the order, right? So I'm going to go ahead and flip the order. So instead of having a, I'm going to have a plus n minus 1 d plus a plus n minus 2 d plus a plus n minus 3 d, and so on. And finally, I will get just plus a. Okay, and like I said, I'm going to now add. I'm going to add these two together. So at first, we have s sub n plus s sub n, giving us 2 s sub n. And now we're going to add the first two terms together, right? We're going to add the first two terms together, giving us 2a plus n minus 1 d, right? So I just added the a's together, and then I still have n plus 1, or n minus 1 multiplied by d, right? So now let's go ahead and add the second terms. Now we get 2a plus n minus 1 multiplied by d. And if we add the third terms, we're going to also get 2a plus n minus 1 d. And finally, our last term is going to be, yep, you guessed it, 2a plus n minus 1 d, right? So in this case, we have, let's say, 1d, and we're adding negative 2d, so it would give us negative 1d. Next term, we have 2d, and we're adding negative 3d, giving us negative 1d. So you see how for any term, we're going to always get back to negative, or n minus 1 multiplied by d. Now, if we go ahead and collect like terms and simplify, we get n multiplied by 2a plus n minus 1 d all over 2, right? Because we're isolating for s sub n. So what happened here? Well, we simply have our 2a plus n minus 1 multiplied by d. That is the term that we deduced previously. And we're multiplying it by n, because if we're looking for the third term, it's going to be this. It's going to be this. I should have used a different color, but regardless, it's going to be this multiplied by 3, because we have 3 sets of the entire equation. And then we're simply solving for just s sub n, so we're dividing by 2. Right? So if this looks familiar, well, it should look familiar. This is our first formula. This is our first formula. That's great. Now, how do we go about solving or deriving our second formula? Well, it comes from the first formula. So I'm going to go ahead and try to squeeze it in at the bottom here. So what is happening in our second formula? If we remember our second formula, I'll write it up in purple, is s sub n is equal to n divided by 2 multiplied by a sub 1 plus a sub n, right? That's our second formula. So what's happening here? If we were to go ahead and break apart this 2a, if we were to go ahead and break apart this 2a to get s sub n is equal to n divided by 2, a plus n minus 1 multiplied by d. So all I did here is I broke apart this 2a to be a plus a. That's it. So now, do you see where we can get our second formula from? Well, we have it already. So we have a sub 1, our first a, and then what is all of this? What is a plus n minus 1 multiplied by d? Well, that is simply any term, right? Because all our terms are a plus n minus 1 multiplied by d. That is the sequence, or that is what the definition of a sequence is. So this could be rewritten as a sub n. And that's it. We just derived both formulas. Again, I'm not going to ask you to derive them on a test, but it's useful to know where they come from, and hopefully it helps you in using the formulas to solve for various questions.